right. Short live stream. Okay. All right. So, welcome everyone. Hopefully this is working. I'll play some classical music while we're here. Okay. Start this one. Okay. Right. So we will go here. Check. Kernel dev in C. Alright, this will be a short stream, so around 30 minutes. Because I will have to go somewhere else after this. Let me share the screen. Okay. So, hello everyone. We will start right now, quickly. So, first I decided to switch to Sway because I think it's nicer. Not sure, I forgot. Not sure how I can resize things. That's okay. So we'll continue. Workspace, and then common.h. So we'll continue with macros. So apparently these are called macros. I've always wondered what it meant. Yeah, these are basically macros. That is a very bad graphics. Okay, so macros. That's fine. Okay. So actually I should configure the editor to recognize that we're not gonna have like standard library. So that's okay. So we define type definitions up here, right? And we will define more macros here. For example, true is basically 1, and that false is 0, right? And then also define that null is a void point 0. It's basically 0. So is not. So what is this, right? This is a so it's this one, right? Is basically a pointer to something not tightly specified. Okay. So it's kind of like, because like we're basically what do you call it? We are casting onto 0. Is that how it works? I think so. I think that's how it works, I guess. Oh, someone's there. Hello. What's up? Right. Then we will align. So align up. I'm not sure what this is. I think there will be an explanation. But if align up is rounds up value to the nearest multiple of align. So, oh, okay. So it's just rounding up stuff, right? So, this align up thing will have value and align. Okay, and then tabs underscore built-in align up value. Interesting. So define. So these ones are basically what are these? Useful when dealing with memory alignment. Oh, okay. So it's macros for memory alignment. Sorry, is it memory alignment? Yeah, because you gotta move the pointer to the memory, or the various pointers when pointing in memory. That you gotta move things around, and this one will help, I guess. Rounds up value from the nearest multiple of alignment. Okay. Checks if value. Okay, so this one is the thing that moves. So the thing that rounds up, and this thing is aligned. Value align. Yep, and then this is built in. Is aligned value. This is the check if rounded up, right? And then define offset of. This is the type or member. This is built-in offset of. It's an offset of something type member. So this thing returns offset of member within structure. Yeah, something like that. So here it says, right? Checks if value is the nearest multiple. Nearest multiple, okay, of align. So this is the nearest multiple. For example, align up 0, 1, 2, 3, 4 to the nearest multiple of yeah, so basically God, I can't believe I'm going back to basic math. Okay, so nearest multiple, you know, yeah, here we go, right? Yep. Just rounding numbers. Yeah. Okay. So here the functions starting with built-in used in each macro used in each macro are Clang specific extensions. Okay. So it's macros and functions. Clang specific. Okay. I can't believe I'm trying. How to find the nearest multiple? How to find the nearest multiple? So, how to find the nearest multiple? I'm just curious. Sometimes I forget things. And yeah. What am I even looking at? Round to the nearest multiple. I don't know if my brain is sleepy or whatever. Hmm. Oh yeah, it's just rounding shit up. A line must be a power of 282 for 8, 16, 32, 64, so on. Okay. Pure C of us interesting. Alright, memory oh yeah, we have to define these ones too. So now that we define the macrons, we'll define the functions, right? So void memset. Oh, I think we left off somewhere. Did we? Yeah. Oh yeah, these ones we already done that. So memory set void. So we're gonna have a buffer, right? A character C, characters, and then size. So it's basically we're gonna set something in this buffer with the character C size n, with of the size n, right? Wait, no. Is it? Is it? Is it? Yeah. Oh, there you go. The mem cpy copies n bytes, right? N bytes from source, which is this, to destination. Ah, yeah. Then I got it correctly. Yeah, it's if you look at the crap. Hold on. If you look at the original, if you look at the C, I can't believe I'm still doing this. I'm still reading a fucking book because this is the goal. Okay, the goal. Right? When it comes to, even though I'm bad at math, I can still rely on this stuff. Oh boy. Yeah. So we will find. It's in the reference manual somewhere. I just need to find the function. Shift. Nope. What is this? That's type def. Nope. It's related to memories. So is the things in the standard library? Is it? Formatted input. Get C. Put character. Q sort. Where is this? This is not it. Hold on. Standard input output. Slash f remove. Set buffer. Print f. Yeah. Direct input. Oh, or is it in the utility functions? Yeah, this is free. Oh, this is malloc. Environment VA. Ah, right. Oh, as I was confused, right here. If you look here, I was confused. What is a VA list? What is a VA start? Right. If you read here on page 254, if you can see, yeah, page 254, B7 in Appendix B, standard library, variable arguments is the header std_arch, okay, which we don't have, but we put it here anyway because we're just implementing a minimal version of it, right? Provides the facilities for stepping through a list of function arguments of unknown number and type, right? Yeah. Declare VA list will point to each argument. So first, so the VA list is that it's a variable list. That's what it stands for. Okay, so VA list is a variable list, right? AP must be initialized with the macro VA start. Yes. VA execution, VAR will produce a value with the type value that unnamed type macro VA end. You know what? I'll show it here because it's best thing if I can show it here. So, what is it again? The C programming language KNR. I don't have it downloaded, I apologize. So, if we go to page 254, is it 254? Oh shit, why is it only... Oh, this is not the original one, is it? Oh, it's fine. We'll look at 209 then. Yeah, here. Where is this? 209. Yeah, look at this, right? The header, right? This is the first stepping through a list of function arguments of unknown number and type. Suppose last argument is last name parameter of function f with a variable number of arguments, right? Then declare f with an f variable type VA list, variable list, that will point to each argument in turn. Okay, so this one VA AP, yes. AP must be initialized once with the macro VA start before any unnamed argument is accessed. So we start by, did we actually wrote this? Kernel, did we? I am unsure about this. Did we? I don't think we did. Oh, is it in printf? Hold on, kernel.h? No, kernel common, no, common. Did we? I'm not sure. I don't think we. Oh, see. If we look here, we first see we were following the standard standard library. Okay, this is how it's supposed to be done, right? So first, okay, so they say okay, there's a last argument is okay, so they have a function f with a variable number of arguments and declare with an f variable of type VA list that will point to each argument. So here we have a function called printf, and since in C, right, if you want to printf, it can either be one argument like this, right? This is sorry, wait, is it? Yeah, this is a one argument, one. Argument or parameter? I always forget. Hold on. Argument versus parameter. I am an idiot. I'm sorry. Yeah, there you go. I should put this on my freaking wall. So here, x, y are the parameters. These are the parameters. But if you do this is an argument. So when you write printf, right? In this case, you know what? Let's make it easier. I am passing only one argument, right, to the function. Now there's only one argument, but at the same time, you can also do this. What is it? You can also have a second argument, right? Because we want to print the integer in this string. So we can have another argument here that, okay, this is the format specifier. Okay, hello plus print this thing, because, and also if you want to print integer, yeah, or print s or something like that, and then you can type s. See, you can, you start to realize that there can be many parameters or arguments that you like, oh shit, how am I supposed to know? Like if you want a hard code, okay, %s, recognize that, and then 1. What if there's another argument after 1? Now there's 3 arguments being passed to the function. What are you going to do about that, right? So that's the entire reason why VA list exists here, I guess, because it helps you basically read the function arguments that was passed, because even though it lets you go through the list of arguments that was passed to that function without having to know the amount of the type or the amount of arguments here. I don't know if that was clear. I don't know. I understood it. I don't know if you guys understood it. I'm sorry. That's all right. So yeah. So according to this, right? So VA list. So first we do this, right? VA list vargs, right? And then VA start must be initialized with the macro. Yeah, so vargs must be initialized once. Here, see, this is where we're following the standard. Following standard, just like knrc stdr.h, right? And then we just do a bunch of shit here, and then the macro, after the arguments have been processed and before the function exits, we must do van. Yeah, that's it. That's how it works, apparently. Yeah, I learned this some time ago and I forgot. You know, it was a long time ago, so it's normal. Yeah. Okay, so if we go back here, the macro void must be called after, something like that. Okay. So we will define the functions here. So memory set, right? This is similar to the standard C. If we check here, not sure you can switch. Yeah, there you go. See? Put the character C, right, into first n characters in the buffer. Return buffer. There you go. This is how it works. Oh, very good. Okay. Let me do void and then mem copy, mem cpy. So we're copying memory. Void destination const void. Yes. So constant source, then size tn. Okay, and then char string copy, because we have to return the string that we copied, I think. S1. Sorry, destination. Oh boy. Char destination const character string of characters source. Well, it's not really a string of characters, but I mean it kind of is. But if you look at this, right, const char, like const char, it's basically a pointer. Source is a pointer to the address Is it a pointer? It is a pointer, right? Pointer to the address that the data of source is stored in. So it's the first address, right? So it's the first, like the base address of the string, of the source string. Yeah, something like that. I think that's how it works. Yeah, if I remember correctly. So then we do string compare const character for string. Oh, we just compare both of these together. Right. Sorry. Test 2. Easy. So, after that, we just quit. Actually, I should make this smaller. And then we go common. Let's see. So here we're basically going to define the common functions that we'll use, right? It's not a big deal. Okay. So, so first we'll define. We'll continue. We'll implement these ones. Void destination const void structure. Source size tn. And this will be unsigned integer. Okay, an unsigned integer. D, and then we're gonna cast destination as that, because destination is where we're copying the source to. Right. Then const uint8, which is the unsigned integer s, and then we're gonna cast it. String source. While oh, I'm an idiot. Sorry. It's already implemented from the it was already implemented here, wasn't it? There you go. It was already here. We already implemented it. So if we was like kernel.c, yeah, we'll just remove this, and then we'll go to, there we go. Yeah, we already implemented this. There you go. So pointer dereferencing, manipulation for clarity's sake. Yeah. Oh, so this one, pointer dereferencing, right? Where it dereferences p dereferences p, then p equals p plus 1. Yeah, something like that, I think. So the pointer, okay, so the buffer, yep, that's the buffer. And this is when the stack n decreases, because n decrease equals stack grows. As the stack grows, we write c to that buffer, which is referenced by the star p pointer, because that thing is pointing to the buffer, right? Yes. Number 1, dereferences p and set p to c. There we go. Then let's do some string operations. So we will do here, right? String, all right. String operations, right? So character, which is strcpy, right? Character destination const char source, then what char d equals destination, just character of destination, and then while we're looping through the source, and apparently they decided not to use the, but I will probably use it just for my sake. D++, which is the same thing here, same thing up here, right? Where you dereference D first and set D to source, and then you increment D equals D plus D equals D plus 1. There you go. Then dereference D and then set that to 0. Sorry, null terminator. Yes. Set to null terminator. There we go. And then return destination. Easy. Yeah, so here, this is the classic thing. As the string copy function continues copying if the source is longer than the memory area of destination. This can easily lead to bugs and vulnerabilities. So it's generally recommended to use an alternative function instead of string copy. Never use it in production. For simplicity, we'll use string copy in this book, but if you have the capacity, try implementing an alternative function, strcpys, instead. So that if you were to do that, which is here, so there's strcpys or strncpy, where it copy at most a specific number of characters. Whew, okay, right. Okay, safer alternative is strncpy. Anyway, so next we'll do the string comparison. So in string comparison, const char -1 and then const string number 2, and then while string number 1 and string number 2, okay, yes, something like that. If the first string is not equal to the second string, sorry, no. We're comparing each one by each character. Well, yeah. Okay, so we're comparing both, looping through the characters. All right, and then this will break because this means what? This means the string is no longer the same. Different char detected. All right, then for the sake of my fucking sanity. Then string 1 plus string 1 2 because we're looping through. We're looping through the string. Then we'll return everything as an unsigned string. Okay, basically returning a string minus. Oh no. Unsigned character. Sorry, it's not. We're not returning a string. We're returning the difference between the two, which is basically, as you can see here, like the return values, right? Of this function here is if s1 equals s2, okay, the same, then the return value will be 0. If s1 is larger than s2 or positive, this will be okay. So this will be a positive value, and if s1 is less than s2, this will negative value. These two basically means that the two strings aren't the same, right? And lastly, yeah, see, alpha and check these strings are identical. It's a bit counterintuitive, but strings are identical. But the strings are identical when not string compare s1 s2 is true, i.e. when the function returns 0. Yeah, if the function returns 0, it's the same, right? That's it. That's it. Yeah. Something like that. All right, that should be done. That should be it for our standard library implementation according to this book. Implemented memset memcpy string. Is it memset? Oh, sorry, memcpy memset, yes, and then string copy and string compare along with other useful macros. Git push. The name is not available. Oh, okay. Give me a moment, y'all. I have to put this up. There's SSH. Why is it not remembered in SSH? That's weird. Oh, hold on. Username. Yeah. All right. All right. Everything should be on there now. Shown in this commit over here. Dionysios. Yeah, there we go. We just implemented it as I have said here. We will continue again tonight, hopefully. Kernel, right? C standard, minimal standard library implemented. strcpy, str memset, memcpy, strcmp. Then I'll just copy the commit here. All right. Well, thank you everyone for watching. We just finished this, and oh shit! I just realized I just leaked my GitHub token. That's all right. I'll revoke it. Don't worry. Oh boy, I just leaked my Lamau. It's okay. Well, I'll see you all later. Thank you everyone. Bye bye.